What's up guys, this is Massey. Welcome to another video. This video I want to talk about solubility and precipitate formation. I have two examples for you. The first one, it says a 50 milliliter sample of 0.002 molar of silver nitrate. It is added to 50 milliliter of 0.01 molar NaIO3 sodium iodate. What is the equilibrium concentration of silver in solution? KSP for silver iodate is 3 times 10 to the power of negative 8. So first thing, we have 0.02 molar of AgNO3 and the volume is 50 ml. On the other hand, we have 0.01 molar of sodium iodate. It is 50 ml as well. So if you want to find out the number of moles of Ag, it's going to be 0.002 times 0.05. That's going to make it as 0.1 millimole. Now I want to find out the number of moles of iodate. That's going to be 0.01 times 0.05 times 1000. That's going to be 0.5 millimole. Now Q is Ag times IO3. When you multiply them, it's going to be 0.5 times 0.1 divided by volume, which is going to be 0.002 times 0.01. That's going to give me 2 times 10 to the power of negative 5, which is bigger than KSP, so it means that we have precipitate formation. If I write the precipitation reaction, solid is going to give us these two ions. We have 0.5 millimole of iodate and 0.1 millimole of silver. When they react, it's going to be 0.1 minus 0.1, here 0.5 minus 0.1, which is going to be 0.4. This one is going to be 0. So now we have initially 0 nitrate and we have 0.4 divided by 100 ml, which is 4 times 10 to the power of negative 3. So when you have the ice table, the equilibrium concentration for Ag will be x plus 0, which is x. For iodate, that will be x plus 4 times 10 to the power of negative 3, which is approximately 4 times 10 to the power of negative 3. So KSP equals to 3 times 10 to the power of negative 8 equals to x times 4 times 10 to the power of negative 3. It means that x will be 7.5 times 10 to the power of negative 6 mole per liter. So that's the concentration of silver ion in the solution. In next example, it says a solution is prepared by mixing 50 milliliter of 0.1 molar of lead nitrate with 50 ml of 1 molar of potassium chloride. Calculate the concentration of lead and chloride at equilibrium. So that's going to be the concentration of Pb will be 0.1 times 50. That's gonna be 5 millimole of Pb2 plus. Number of moles of Cl will be 1.0 times 50 millimole of chloride. On the other hand, when you calculate Q, we have PbCl2. It's going to give us Pb2 plus 2Cl minus. So Q will be Pb, which is 0.1 times chloride. That will be 1 to the power of 2. That's much larger than KSB. KSB is 1.6 times 10 to the power of negative 5. That's much larger. So precipitate forms. When you have the reaction, we have PbCl2. It's going to give us Pb2 plus 2Cl minus aqueous. When they react, we're going to have 45, because 50 minus 5 is going to be 45. 45 millimole actually it's going to be 50 minus 5, let's put it this way, times 2. That's going to be 50 minus 2 times 5 is going to be 40. It's going to be 40 millimole. Divided by the total volume, which is 50 plus 50, that's 100 ml. So 40 divided by 100 is going to be 0.4 molar. So KSP will be X, which is coming from Pb, X plus 0.4, which is coming from chloride, to the power of 2, because here the coefficient is 2. KSP is 1.6 times 10 to the power of negative 5 equals to X times. I can neglect X comparing to 0.4, so it's 0.4 to the power of 2. So X will be 1.6 times 10 to the power of negative 5 divided by 0.4 squared, which is 0.16. When you solve it, that's going to give me 1 times 10 to the power of negative 4 mole per liter. That's going to be the concentration of lead in the solution. Concentration of chloride, we already found it. That's going to be 0.4. So the concentration of chloride is 0.4. Concentration of Pb2 minus 2 plus is going to be 1 times 10 to the power of negative 4 mole per liter. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.